Hi students, welcome back to the presentation on basics of power systems. Uh, in the last video lectures, we discussed about operation layout and operations of hydropower stations and thermal power stations. In this video lecture, we will discuss about nuclear power stations. So here also we will start the discussion with the layout of nuclear power plant. What are their basic components, what is their working, their advantages and disadvantages, we will discuss now. This is about the layout of a nuclear power plant. In a nuclear power plant, heat energy is generated by a nuclear reaction called as nuclear fission. Here the nuclear fission of heavy elements such as uranium or thorium is carried out in a special apparatus called as a nuclear reactor. A large amount of heat energy is generated due to nuclear fission. Okay, the rest of the parts of a nuclear power plant are very similar to a thermal power plant, conventional thermal power plant. So what is the main advantage of this nuclear power plant means here transportation cost of fuel is very much reduced when compared to the thermal power plant. Why means it is found that the fission of only 1 kg of uranium produces as much heat energy as that can be produced by nearly 4,500 tons of high grade coal. Okay, so this considerably reduces the transportation of fuel, transportation cost of fuel, so which is a major advantage of nuclear power plants. Also there are large deposits of nuclear fuels available all over the world, and hence nuclear power plants can ensure continued supply of electrical energy for thousands of years. About 10% of the total electricity of world is generated in nuclear power plants. So uh, now coming to the basic components, before going to discuss about the basic components of the nuclear power plant, here first of all we will make clear upon what about the nuclear reactor, what happens in the nuclear reactor. So what do you mean a nuclear fission? So now we will discuss. Just go through the some chemical equations. See here, this animation slide will give more explanation about the nuclear fission. See here, what happened in the nuclear fission. So this red color neutron, here you observe, this is the red color neutron. When you combine with the uranium 235, okay, it will produce an unstable uranium 236, which will split up into a two fragments, and it will release three extra neutrons, and also enormous heat is developed. Okay, see, observe here in this animation they will clearly show. See here, one neutron hit this rod and it will split up into three. Again this will hit the rod, again it becomes three, again it multiple things are there. So that's why this is about only one atom. When you compared with the sorry, when you same case is applicable with more number of atoms like this, it is a more amount of energy is developed. See, coming to this chemical equation, so this is a chemical equation for this nuclear fission. See here, when you combined one neutron with the U92 235 uranium natural, it will produce an unstable uranium 236, which will divided into two fragments, that is krypton and barium. In addition to these two, three more neutrons is released, and in addition to all these, one of the main thing here it is enormous heat is enormous energy is developed in the form of heat. So how much means nearly 202.5 mega electron volt. This is only for one atom only. Like this, there are several atoms are there. See here, several atoms. So that's why enormous heat is developed. So that heat energy we are going to utilize for the see this and heat energy is transmitted through this heat exchanger. So just like similar to our conventional thermal power station, here water is passed through this heat exchanger. Since heat is transferred to this heat exchanger by nuclear reactor, so this water becomes steam. This steam is passed through the turbine, steam turbine. Then steam turbine will rotate. So anyway, we need a mechanical energy. Here the mechanical energy is developed by means of steam. So how that steam is developed means the heat energy taken from the nuclear reaction is taken. That heat energy is used to convert the water into steam. Is it? Okay. Now we will see what are the basic components. Here these are the seven basic components in this nuclear power plant. So here the nuclear reactor and a circulating coolant circulating pump, heat exchanger, heat exchanger, and feed water pump, a condenser. These are the same thing. These are the common points here. From heat exchanger to generator, these are the common things. Only the two things are nuclear reactor and coolant circulating pump. These two are different when compared to the thermal power stations. Coming to the nuclear reactor, it's a special apparatus used to perform nuclear fission. Clear? So here coming to the nuclear reactor, it is a special apparatus used to perform nuclear fission. Since the nuclear fission is radioactive, the reactor is covered by a protective shield. This is very important. This is covered with a protective shield. Splitting up of nuclei of heavy atoms is called as a nuclear fission. Just now we've seen in the last slide how the animation will show the nuclear fission, during which huge amount of energy is released. Nuclear fission is done by bombarding slow moving neutrons on the nuclei of heavy element. So as the nuclei break up, it releases enormous energy as well as more neutrons, which further cause new fission of neighboring atoms. Hence, it is a chain reaction. So it must be controlled, otherwise, it may result in explosion also. Very dangerous. So a nuclear reactor consists of fuel rods. Here the fuel rods are there, control rods also, and moderator. A fuel rod contains a small round fuel pellets, uranium pellets, uranium or thorium. Control rods are of cadmium, which absorbs neutrons. So this controlling operation will be done by these control rods. These are made up of cadmium. They are inserted into the reactor and can be moved in or out to control the reaction. The moderator can be a graphite rods or the coolant itself. The moderator slows down the neutrons before they bombard on the fuel rods. Clear? The next one, uh, heat exchanger. In the heat exchanger, the primary coolant transfers heat to the uh, secondary coolant, water. Thus, water from the secondary loop is converted into a steam. Into a steam. The primary system and secondary system are a closed loop, and they are never allowed to mix up with each other. Thus, heat exchanger helps in keeping secondary system free from radioactive stuff. Heat exchanger is absent in boiling water reactors. Okay, so these two are separate. Next, feed water pump. This is already seen in our thermal power station in the last video itself. So water after circulate after the steam coming from this turbine, it has to be condensed to heat exchanger, and from there by the use of circulating pump, it sends to the concrete shield system. Okay, and coming to the steam turbine, it is a common component in the thermal power station also. So which the generated steam is passed through a steam turbine which runs due to the pressure of the steam. The steam turbine is coupled to an alternator through a rotating shaft. So now it will shows this working of a nuclear power plant. Here it clearly indicates a nuclear reactor. This is a nuclear reactor which consists of reactor core. This is a reactor core and the heat exchanger. These pipes are called as a heat exchangers. These are heat exchangers where the heat is developed in from the reactor core. So these are the fuel rods and these are the control rods. Okay. So here the nuclear fission takes place. From the nuclear fission, heat is developed. That heat is transferred to the heat exchanger. So in the heat exchanger, a cold water is passed through this. This cold water becomes steam due to the heat exchanger, and this steam is sent to the steam turbine. The steam turbine will rotate. This steam turbine is connected mechanically to the shaft of the generator. So that's why the generator will move. Generator will rotate. Okay, this rotation of this generator will convert the mechanical energy into electrical energy, and that energy, electrical energy, is transmitted through the transmission lines. Okay, so coming to the turbine again, after passing the steam through the steam turbine, the same steam is passed through the condenser. Here again that steam converts into a water, and again this water is fed back to the heat exchanger. So this is the entire process here. And coming to the advantages of the nuclear power plant, when compared to the other plants, it requires very less space. Here there is no need of construction of any dam, like unlike hydropower plants. And here there is no coal handling plant in thermal power stations. Here only reactor is enough. Only 1 kg of uranium will generate more amount of energy. So a simple reactor is there. The remaining thing is common. Okay, similar to thermal power station, and it will be well suited for large demands. Large demands means whenever high power generation is required, at that time this will it will be perfectly suited for large demands. And the fuel consumption is less, and transportation cost of fuel is also very less. Here by using this nuclear fission nuclear reaction, we can generate more amount of heat energy. So that's why the high capacity of the plant can be installed. So compact, it is more compact and simple in maintenance. Okay, coming to the drawback. So here by the means of construction of this nuclear reactor, okay, it needs a high initial cost. And one more important drawback here, it is operating with radioactive elements, that is uranium, thorium, etc. It is a danger of radioactivity hazards is always persisting. The disposal of fission products is a big problem. Is it right or not? Here, nuclear chemical products coming from this nuclear fission is disposal of that products in this nuclear fission is a big problem, and maintenance cost is always higher. Okay. Working condition is always detrimental to the health of the workers. Always it's very dangerous to operate under radioactivity elements. So that's why that nuclear reactor is provided with a protective shield. So so these are the disadvantages of the nuclear power plant. Thank you. If you have any doubts, please post it in the comments or in WhatsApp or through mail. Thank you.